Good day everyone. Our topic for today is dead loads and live loads. But first, let me define structural load. Structural loads are an important consideration in the design of buildings. Building codes require that structures be designed and built to safely resist all actions that they are likely to face during their service life, while remaining fit for use. Minimum loads or actions are specified in these building codes for types of structures, geographic locations, usage and building materials. There are two types of structural loads: the dead load, and the live load. The dead load includes loads that are relatively constant over time, including the weight of the structure itself, and immovable fixtures such as walls, plasterboard or carpet. The roof is also a dead load. Dead loads are also known as permanent or static loads. Building materials are not dead loads until constructed in permanent position. Therefore, the dead loads for a structure comprise the weights of the floors, beams, and girders, the floor slab, roofing, walls, windows, ventilation, electrical fittings, and other miscellaneous fixtures. In some cases, a structural dead load can be estimated satisfactorily from simple formulas based on the weights and sizes of similar structures. Refer to National Structural Code of the Philippines for the densities for design loads from materials and minimum design dead load used in construction for local standards and specifications. Live loads, or imposed loads, are temporary, of short duration, or a moving load. These dynamic loads may involve considerations such as impact, momentum, vibration, slosh dynamics of fluids and material fatigue. Live loads can vary both in their magnitude and location. They may be caused by the weights of objects temporarily placed on a structure, moving vehicles, or natural forces. The minimum live loads specified in codes are determined from studying the history of their effects on existing structures. Usually, these loads include additional protection against excessive deflection or sudden overload. Refer to National Structural Code of the Philippines for minimum design live load used in construction for local standards and specifications. For example, the building wall consists of 8 inches clay brick. In the interior, the wall is made from 2x4 wood studs, plastered on one side. If the wall is 10 feet high, determine the load in pounds per foot of length of wall that the wall exerts on the floor. In order to solve what is asked in the problem, refer to the National Structural Code of the Philippines. The formula is L is equal to load of the clay brick wall, multiplied by the height of the wall, plus the product of load of wood studs and the height of the wall. Based on the table flashed earlier, substitute the standard values and solve the equation accordingly. 79 pound per foot squared, times 10 foot, plus 12 pound per foot squared, times 10 foot is equal to 910 pound per foot. Therefore, the load that the wall exerts on the floor is 910 pound per foot. Next, the floor classroom is made of 125 mm thick lightweight plain concrete. If the floor is slab having a length of 8 meters and width of 6 meters, determine the resultant force caused by the dead load and live load. The first thing to do is to compute the dead load by multiplying the load of floor by the length and width of the floor slab. By substitution, substitute the values from the table discussed earlier. This gives a dead load of 90 kN. After that, proceed in computing the live load by multiplying the minimum live loads for classrooms, with the length and width of the floor slab. The values can be found at the table of minimum live loads. This gives 92.16 kN of live load. Finally, we can compute for the resultant force by adding the dead load and the live load. 90 kN of dead load, plus live load of 92.16 kN is equal to 182.16 kN. Therefore, the resultant force caused by the dead load and live load is 182.16 kN. And that concludes our discussion for today. Don't forget to subscribe and hit the notification bell to get updated. See you in my next video.